Hey, what's going on, guys? In this video we are going to see how to solve this transistor circuit using this formula, this pattern. This is the equivalent model of this one. This model is equivalent model of this one. If you want to know how to solve like using this model, keeping this model, I have made a video on that previously. You can go ahead and watch that. I used mesh analysis to solve that, but here we are going to use node analysis to solve this equivalent model. Okay. Now here we are going to find out what is this IE current, and also we are going to find out what is this V sigma voltage. These are the two things, and also we are going to find all the currents and stuff. Now let's go ahead and see how to solve using node analysis. So let's say this current going through this is I1, and let's say this is I3. Let's say this current is I2. So according to node, here we can use Kirchhoff current law. Kirchhoff current law says whatever the current entered through the node should be the equivalent to the current exist through that node. So I1 is entering, I1 is equal to I2 and I3 are exiting. So I2 plus I3. Now I1 is 2 minus 0.7 because this 0.7 here, so the same voltage will be here as well. So 2 minus 0.7 and the resistor in between, that is 100k. So this is going to be 2 minus 0.7 divided by 100k. That's equivalent to I2. I2 is nothing but 0.7 because this voltage will be here. So 0.7, this is ground. So 0.7 minus 0, that's 0.7 divided by 200k. 0.7 divided by 200k plus I3 is 0.7 as well, connected to the ground, so it's just 0.7. okay, actually it's connected to the base, so we can directly write IB right here. Instead of calculating the current, we can just, because we don't have any resistor, so we can put it as IB, and we can solve for IB, base current. Okay, so base current is going to be equivalent to 1.2 minus 0.7, that's 1.3 divided by 100k minus 0.7 divided by 200k, and if you calculate this one, you will get 9.3 microampere. That is IB. And from through this here, if you look at this one, this mesh here, actually this loop here, here we have a dependent current source that is 150 IB, and only current passing through this is IE. So IE is equal to 150 IB. We can solve for IE then. IE is equal to 150 IB, and 150 times 9.3 microampere, and if you solve for this one, this is going to be 1.425 milliampere. This is IE. Then we have to find out what is V sigma is. V sigma is here. To find out V sigma, we can use KVL in this loop. Apply KVL in this loop. So V sigma plus 100 IE, actually 1000 IE minus 16 is equal to 0. Therefore V sigma is going to be equivalent to 16 minus 1000 times IE is 1.425 milliampere. So this is going to be 16 minus 1.425, and that is equivalent to 14.575 voltage. That is V sigma. And that's it. Our purpose is to find out IE and V sigma. We found out both of them using this equivalent model, and we used for the previous one we used mesh analysis. Here we used nodal analysis, and that's how it's done. I hope you guys find this video helpful. Thanks for watching, and if you are trying to learn electronics, there are a bunch of videos in my playlist. I hope you guys watch that too, and don't forget to subscribe. See you next time.